Welcome to this video on HVAC processes. In this session we'll focus on how air moves across the psychrometric chart as it undergoes a heating, cooling, humidification or dehumidification. This visual understanding is key to both design and troubleshooting. In this video we'll explore three essential aspects of HVAC processes on the psychrometric chart. First, we are going to talk about why understanding the chart matters for HVAC diagnostics and design. Then a preview of the characteristic paths for each process, and last, how these paths relate to the human comfort zone defined by Ashrae. Each of these will help you to read the chart like a designer. By the end of this short video, you should be able to clearly describe the 6 main HVAC conditioning process and recognize how each one is represented visually on the psychrometric chart. Take a moment to review these learning objectives carefully before we dive into the lesson. They will guide everything we cover next. Before we dive into the chart, consider this. Have you ever walked into a building and felt uncomfortable? Even when the temperature seemed just right? Maybe it felt damp, dry, or stuffy. That sensation often has more to do with moisture than temperature. Could you explain what process might be missing in the HVAC system of that building? Now imagine using a psychrometric chart to uncover that hidden discomfort. How might it reveal the missing pieces in air treatment? Thinking in terms of processes, not just temperature, can completely change how we approach comfort and system design. Why is this important? HVAC systems condition air by changing its temperature, humidity, or both. Each process leaves a distinct trace on the psychrometric chart. Understanding this helps you to diagnose system performance, design better air handling strategies, predict thermal comfort outcomes. This foundational knowledge will support everything from system sizing to energy control. In this psychrometric chart is a simplified preview of the paths we'll explore. We can see here sensible heating going in a straight line to the right, sensible cooling in a straight line to the left. We have cooling plus dehumidification, just slope down toward the left. Heating plus humidification in a slope up and right. Evaporative cooling, the diagonal up to the left along constant enthalpy line, and a mixing that is from two different states is a line that joins these points. Before we wrap up, let's briefly touch on why these processes matter beyond the energy and airflow. Comfort. HVAC systems are meant to keep people feeling comfortable, and the psychrometric chart helps us define what that means. Ashrae defines a comfort zone, and typically in terms of dry bulb temperature and relative humidity, where most people feel thermally comfortable. This zone is often between 22 and 26 degrees Celsius and 40 to 60% relative humidity. Understanding where this zone lies helps us to target conditioning efforts to land within it, avoid over-humidifying or over-drying the air, and visualize whether our HVAC strategies will deliver comfort. So if we have, for example, a state point here, this visual tool helps us to know that we stay towards the comfort area. So, psychrometrics give us a powerful tool way to understand HVAC processes visually. Learning to recognize these paths is one of the most valuable skills in HVAC design. It prepares you for deeper analysis and smarter decisions in the next stages. We have here the key takeaways. So, first, HVAC processes are more than just temperature changes. They involve moisture and energy exchange. Then each conditioning process follows a distinct path on the psychrometric chart. And finally, understanding the comfort zone help us guide effective system design. Well, this is just the beginning. Now that using how HVAC processes appear on the psychrometric chart, it's time to dive deeper. In the next video, we'll explore sensible and latent conditioning in more detail, how heating, cooling, and dehumidification change the air. Then we look at evaporative cooling and air mixing, and how these passive or low energy processes behave differently on the chart. Finally, we'll apply what you've learned in real HVAC design examples that use psychrometrics to guide decisions. Thanks for joining me. See you in the next video. We should move the